Limits and derivatives. So in the miscellaneous exercise we have completed 29 questions. Now the last one, the 30th one, which we'll clearly understand in this video. Now let us find the derivative for the 30th one. So the function is x divided by sine to the power nx. We have to find the derivative d by dx of the function, which is also denoted as f dash of x, right? So we have to find derivative of this function. So first let us label the function. Let f of x is equal to x divided by sine to the power nx. Now we want f dash of x, so we have to differentiate. Differentiate both sides with respect to x. We have d by dx of f of x is equal to d by dx of x divided by sine to the power n of x. So d by dx of f of x, which we also denote it as f dash of x, is equal to d by dx of function by function. So we will apply u by v rule, right? So u by v rule, so in the denominator it is v square, so we have to write sine to the power n x the whole square into sine to the power n x d by dx of x minus x into d by dx of sine to the power n x. Now this implies f dash of x is equal to, now in the denominator, so how we are going to write here? Sine to the power nx the whole square. So when you have sine x the whole square, you will write sine square x, right? Now if you have sine square x to the power square, you have value here. So how you are going to write it? Why did you write 2 here? When you had 1, you multiplied 1 into 2, 2. So here you will write 2 into 2, you will write 4x, right? So you're going to multiply. So now you have sine to the power nx the whole square. So this will be, how you're going to write it? You have to multiply. So n into 2, n2 or 2n, both are same, x. Okay, so in the denominator you will write sine to the power 2n x. So I'll just write the bracket to avoid confusion. Okay, now let us solve the numerator. Now sine to the power nx, derivative of x is 1. How do we get it? By using the power rule, x power 1. So you apply this, x power 1, you will get 1 into x to the power 0, which is 1. So derivative of x is 1 minus x into d by dx of sine to the power nx. Now you have to be careful how you're going to find the derivative of this. Okay, will you apply u plus v rule? U plus v rule or u minus v rule or u into v rule or u by v rule? or lambda into f of x, or constant into function. So which algebra of derivative you will apply here to find the derivative of this function? Sum of function, difference of function, product of function, quotient of function, constant into function? None of this. None of this you will apply here to find the derivative. Okay, because there are no operations such as sum, product, difference or quotient here. We have to apply chain rule. We have to apply chain rule. Here the function is composed of one another. They're clubbed. So you have two functions here. One is the outside function, inside function. Okay, this is of this form, outside function and inside function. So which is the outside function here? Let me just take out this. Which is the outside function here? That is x to the power n. See, sine to the power n and x to the power n. And there is also one more function here, that is sine x. So the two functions are clubbed here, and you have got a function that is sine to the power nx. So we have to apply chain rule to find the derivative of this. Okay, so the first is we have to differentiate the outside function f dash, then we will differentiate the inside function, that is g dash. Okay, so here first we will apply x power n, which is the outside function here. So you will get n into x to the power n minus 1, but in the place of x we have sine x, right? And to the power n minus 1, you should not write here. Where is the n exactly? Here, right? So here you will write n minus 1. Okay, now we will differentiate the sine function, that is the inside function. So when you're differentiating the inside function, you don't write n because it is already differentiated. So you just need to write this sine x. Okay, now this implies f dash of x is equal to, so here you will get sine to the power n and then x minus n into x into sine to the power n minus 1 x. So we'll put the brackets to avoid the confusion. Here also we'll put the brackets to avoid the confusion. Then derivative of sine x is cos x. In the denominator it is sine to the power 2n x. Now this implies, so here we have sine to the power nx, sine to the power n minus 1x. So we can take common, right? So when we are taking common, we will always take the lesser value. So here n is bigger compared to n minus 1. So we will take the lesser one as the common. So we will get sine to the power n minus 1 x. So if you take common sine to the power n minus 1 x, so out of n you're left with just 1 sine x, right? Now if you add these two, you have to get it back. If you add these two, you have to get it back. So you add the exponent here, add the exponent, that is n minus 1, and here there is 1. Add the exponent, you will get n, plus minus 1 will go, you're just left with n. So when you split it and if you add, you have to get back the same value. Okay, then minus nx. So from sine to the power n minus 1x, you have taken all sine to the power n minus 1x, so you're just left with 1. We'll not write that, we'll just write the cos x value. then divided by sine to the power 2n x. Now we have the same sign terms in the numerator and denominator, but we have different power. So how we are going to solve this? So in the law of exponent we have studied, when you have a to the power m, so how we are going to write in the reciprocal form? You will write 1 divided by a to the power minus m, right? So if you have a power m, you will write 1 divided by a to the power minus m. Now this value, that is sine to the power n minus 1 in x. So how we are going to write it? You will write 1 divided by sine of minus n minus 1 x, right? We are writing brackets because this minus is applicable to both the terms. Now this will be 1 divided by sine of, now let us multiply, minus n plus 1 of x. Correct? So now you got this in the bottom. So how we are going to write it? So this implies f dash of x is equal to, we will write sin x minus nx cos x. So in the denominator you will get sine to the power 2n x. Then you have brought it down, right? You have brought it down. So what you have to write? You will write sine of minus n plus 1 x. So now here also you have the base sin x, here also you have the base sin x. So when you have the same base, you will add the exponents, right? So how you are going to add the exponents? When you have the same base, you will write 2n minus n plus 1. So if you add the exponents, you will get 2n minus n will be n plus 1. So therefore f dash of x will be sin x minus nx cos x in the denominator sine to the power of n plus 1 x. So this is the derivative of the function x divided by sine to the power nx. Completed all the exercise problems in the limits and derivatives.